Okay, perfect. All right. Well, this morning I'm a little low on coffee, so I'm a little low in learning mode, but that's okay because the brain power here combined is through the roof. I'm the least technical person here, but though I feel like I'm getting a PhD already. Just by way of introduction, I am Sheng Nan. I'm part of the Wells Fargo Corporate Ventures team. I invest into companies that are strategic to Wells. I focus on enterprise software, specifically in cybersecurity and AI. And I focused on investments in the Series A plus stage. And we have our panelists. Let's just dive in. All right, awesome. So just to start, maybe just going down the line, if you could please introduce yourself, what you've been working on, and just to as starting icebreaker.
Yeah, so I will go first. Hello, everyone. My name is Zhongzhu, and currently I'm a senior research scientist in Together AI, and I'm mainly focused on the efficient machine learning system, algorithm, and modeling building. And recently, I built our own RL training system in Together AI, and also published agentic data sets called the CoderForge to train the agent model. It's an open source model dataset which is useful and efficient for training like a mid-scale model. Yeah, thank you.
Hi everyone, I'm Xiaolong and I'm a PhD student at Purdue. So my main research focus is on code agent and code model. And recently I interned at Microsoft Copilot team, and this summer I will spend my time in AWS coding team.
I'm Xinpeng, and I'm currently a member of technical staff at Amazon AGI SF Lab. My focus is on reinforcement learning systems, and also this year a lot of agent infrastructure.
Hi, I'm Tianyu Zhang. I'm currently a PhD student at Mila with Professor Joshua Benju. I'm also joining a startup training large language model in charge of the both pre-training and coding agents. Thank you.
Awesome. Well, let's start with the Tianyu. How far are verifiable rewards actually pushing reasoning capabilities, and where do they fundamentally break down?
Well, I think there are a lot of tasks that is very long sequence, which means it takes the agent a long way to reach there to get the apple. So without a process reward, a reliable process reward, probably the reward is going to be too sparse. And we don't know until at the end of the whole trajectory. So the agents probably going to lost in the middle. Sometimes, for example, during coding agent, it could has behavior like reward hacking. And another situation is like there are some, for example, compute use situation. We don't have a application scenario that is fully verifiable, but it's also needs long horizon. How do I say verification of a lot of how do I say for example Photoshop, for example like Amazon shopping situation. Yeah, and we need to have more uncrackable or verifiable process reward so that it's easier to handle. Otherwise, for current model capability, probably the verifiable reward framework cannot handle the whole long sequence reasoning process. Yeah.
Awesome insights. And Xipeng, next question is for you. Since from the research side, you're one of the first few people who has actually lived with these systems once they're out of this world. How do you stop models from gaming the verifier versus generally improving the underlying reasoning?
Yeah, I think this is a very timely question. We've been seeing a lot of reward hacks when training agents this year. For example, in our coding agent, sometimes instead of fixing the bug, it directly pip install that package from the public internet and pass the tests. Others have also noticed this problem. I remember there's a blog post from Berkeley where they show that they could achieve nearly perfect scores on all mainstream benchmarks like Bench Verified, Terminal Bench, Web Arena, etc., without actually completing a single task. 2 weeks ago, I attended MLSys, and Mark Sorofin, the founder of GPU Mode, also shared various reward hacks they found in kernel benchmarks. And our current solution is very straightforward. Whenever we notice a reward surge during training, we analyze those rollout trajectories and identify reward hacking patterns and come up with patches to fix them. A more efficient way, in my opinion, would be that we have a stronger model and we just prompt it to try to break the system, to hack the eval, and we collect all the vulnerabilities it found and fix them in one pass. But this still feels a bit whack-a-mole. A more principled and long-term solution, I think, is to use AI to fight AI, which also seems to be Mark's view from his keynote at MLSys. We can train a cheater, an auditor, and a problem author and a competitor all together, hoping that the auditor can get improved by observing new cheating patterns, and the competitor can also get improved by working with the problem author to solve better questions. This way, we can also move human out of the loop so that it can be more scalable. Yeah, that's my answer.
Thank you. Yeah, I keep on wondering if they keep on cheating, how do we even catch it? So Xiaoyi, question for you, since it's a company that you build to catch this kind of stuff, what kind of benchmarks best predict real-world agent performance beyond math and coding tasks?
Beyond math and coding tasks.
Mm-hmm.
I think my expertise is on coding agent. So I think on coding agent is the most useful task. The most useful benchmark is Evo Cloud and the switch chain. So basically, current most benchmark focus on single issue solving. So basically, agents solve single issue individually. But if you look into our daily workflow, we solve issue sequentially. We solve one issue, second issue, third issue. But for this benchmark, Evo Cloud and switch chain, researchers find that if the coding agent wants to finish issue sequentially, the performance will drop a lot because the error will accumulate during different issues. So I think it reminds us, if we want to do training, we should have this more long horizontal sequential issue environment besides like three bench task. And also another benchmark is program bench. So it's from Stanford. People want to use coding model to replicate a program from scratch. I think it's a very good benchmark, but maybe it's not a good test suit for training. So overall, I think sequential issue solving will be a future environment for code model training. Yeah, thank you so much.
Awesome. Well, quick lightning round, just one word. Going down the line, maybe from my right to left. Larger models, better environments, or stronger verification?
My first?
If you don't mind.
Okay. Sorry, could you repeat the three?
Sure.
Yeah.
Larger models, better environments, or stronger verification?
Better environment.
I agree, better environment.
Larger models.
Ooh,
I'm a true believer of scaling law.
Well, I think all of them are very important.
But you can only pick one.
I would say better infrastructure. Yeah.
That wasn't even one of the choices. But sure, we'll allow that. All right, so next question for whoever wants to answer it. Now we're moving on to the topic of related to where the next dollar goes. So the question is, for long horizon reasoning agents, what matters? Sorry, my apologies. For what are currently the biggest system bottlenecks or large scale agentic RL? Rollout, generation, memory, evaluation, or distributed scaling?
Sorry for being late.
It's okay.
Hey, everyone.
Do you want to actually first introduce yourself and also what research you've been working on or projects?
Yeah, sure. Hey, everyone. Sorry for being late. Stuck on the road a bit. So I'm Xiang Yi. I'm the founder of BenchFlow. We work on evals and data for improving agents and models. We recently made ScaleSbench, CloudSbench, which are pretty popular. And we recently launched our 1.1 version at Google DeepMind. So, yeah.
Okay, awesome, perfect. Actually, this question is for you then. So how do you prevent multi-agent systems from merely reinforcing each other's mistakes, but instead of truly cross-checking reasoning?
One thing you can do is you let an agent audit the trajectory of the agents. So one challenge in that is how do you manage the cost in auditing the trajectories? One thing we found pretty effective was to use Gemini 3 Flash, which is a cheap model and also pretty capable of diagnosing potential reward hacking or error cascading in the trajectory.
Awesome. And going back to Zhongzhu, when I started asking the question, what are some currently the biggest system bottlenecks for large-scale agentic RL? Rollout, generation, memory, evaluation, or distributed scaling?
I think this is a good question and very critical. My point is rollout and evaluation part is currently the biggest issue in the I/O, at least in our system. For large scale, it's not only about the training, not only about the GPU. Like the sweet task, you need to launch like 40K or even larger size of the CPU task at the same time, which need your infrastructural system be very resilient, which means it has the fault tolerance, it has all kinds of infrastructural support to make sure you can run such huge number of CPU tasks during the I/O training. So I think the currently the most critical things or the bottleneck here is how to ensure such system can run smoothly during the I/O training. And I mean, imagine the future. It's not only about the sweet task. It will have all different kind of tasks, including like the searching, the OS, the operating system, or like the real robots. You need to run such kind of real task in the real training. It need scale more size of resources. So it's gonna be, I mean, more bottleneck, more critical issue will happen. We need to have better infrastructure. That's also why I answered the better environments in the last round. Yeah, thank you.
Zhongzhu, you're not off the hook yet. Let's stay with you for a second. Let's talk about the tools that everyone shares, the open source side. How should open source RL evolve to support multi-term autonomous agents at scale?
Sorry, could you repeat the question again?
Sure. How should open source RL stacks evolve to support multi-turn autonomous agents at scale?
I see. I think I already saw a lot of interesting work recently, like the OpenClaw RL. It's actually trained like a self-improvement agent. When you're using the agent, it's improvements by the time. It's using a very clear, beautiful, and a simple idea to train the I/O at the real time. So it's building, it make the agents improved. But I think it's not mature yet. Like there are still a lot of research opportunity or system opportunity together to help agents to real improve themselves. So I would say, in my opinion, we need to build a good system first if we want this question to be true. So, yeah, like an end-to-end real agent system which can learn at the real time, at the inference time. Yeah, thank you.
Sipon, the next one decides whether this is actually affordable to run in real life, in the real world. What trade-offs do you see between reasoning, quality, latency, and the serving cost in production systems?
That's a very good question. First of all, I still believe in inference time scaling, i.e., a higher token budget will lead to better model response. I've seen this in different ways. In my daily uses of coding agents, extra efforts always gives me the best deliverable. In our hill climb reward curves, a longer context length usually gives us a higher eval score. However, as a machine learning system researcher, I deeply understand that the attention computation is quadratic to your context length, and the GPU HBM is not unlimited. Therefore, the model quality, latency, and the serving cost, I think they form a production trilemma. Actually, that's why we have, in addition to Cloud Opus, we also have Sonnet and Haiku. In GPT, we have GPT Mini, GPT Nano, and all those, no matter it is a chatbot or coding agent, it allows you to configure how much reasoning efforts you want to put in this request. In an ideal world, I think it should be that every request is processed by the right model size with right amount of thinking budget. But we were not seeing this widely adopted, even though there are lots of model routing or budget reasoning work out there claiming that they can reduce the cost by a lot without sacrificing the model quality. But why we don't see it used in our products? I think there are technical reasons. For example, the offline eval is different than the online inference, and all those works, they are evaluated on offline eval. But more importantly, I think it's a user experience problem. The user wants both. If a request is routed to a small model and gives them a worse answer, they will complain. And they will also complain if a request is routed to a stronger model, but the inference latency becomes 3x. So they will complain anyway. So just then nobody just use model router and let the user decide what model they want. But actually, I think the agent may finally bring an answer to this question, because as people started saying their cloud code bill become unacceptable, they have no choice but to get over their frustration with inconsistency in like model response.
Awesome. Last two questions. Second last one, Tianyu, questions for you. And then this is one of the great debates. Is process supervision ultimately more scalable than outcome supervision?
Well, I think in a lot of situations, we need to define what is a good stop for a process reward. Like, for example, you need probably some tool call. You can say it's the recall is successful, but probably the tool call itself it's not correct in the whole trajectory. So if you want to validate, how do I say, a chunk of the sequence, you need to make sure that somehow, little bit independent from the context, so that you can easily to you can verify that part easier. And another thing is sometimes these little parts you can score it high if you look at that independently, but in the whole trajectory, it's actually not that important. So I would say it's always a critical problem for credit assignment, even for human. We also do a lot of credit assignments. We need to manage our daily task with a rank of different priority, and I think that's a trade-off. So you need to for long sequence tasks, you need to trade off the how fine-grained your process reward is, vs how sparse the reward you're gonna have. Yeah.
All right, last question, Seonggi. Take us home with this one. It's a big question. Before granting agents strong tool use, autonomy, what minimum evaluation standards should the field agree on?
Minimal evaluation standard as in safety or security or capability?
All of the above, yes.
Okay, so yeah, that's a good question. So this actually will be discussed in our recent Crossbench work. Basically, this is inspired by Agent Harm and Agent of Chaos. In case you didn't miss it, it's a tweet replied by Peter Steinberg on Twitter that's saying, this is not how you should use OpenClaw. Basically, several people on Slack messaging OpenClaw together, and OpenClaw can be prompt injected, giving the wrong people the wrong access of information. Because the OpenClaw that you set up can have access to your whole mainframe or your whole Excel sheet or Google sheet that, let's say, your HR had the HR sheet that the IT people shouldn't have. Basically, we did Crossbench and we did a simulation environment of Cross, Google Sheet, Google Drive, and have several row of people that have different accounts, and see if they can just prompt the OpenClaw at the backend on Slack and retrieve this information. And if it's prompt injected, we'll give it a negative reward. And on top of that, we will give reward based on capability and things like safety. You can't say vulgar things. So far as I know, there isn't. So the model labs are citing benchmarks. I don't think they're citing any agentic security or multi-agent security evals. It's like usually just agent harm or like cyber gem, the cybersecurity. So, but if you really want to deploy the OpenClaw in your Slack production, you want it to not be prompt injected, not be prompt injected by your customer. Say, for example, send your email contains some prompt injection prompts. That is kind of unsolved. So if you like Claude or Codex now has a Slack plugin that lets you read your Slack messages and send Slack messages. So they have an internal filter, but I guess that's the best you can rely on at the moment. Yeah.
Well, you kind of answered some of this question already. We're going to close with the lightning round, going from my left to your right. So I guess if you want to just repeat your answer to this question. Agentic RL won't be solved until we figure out one word or a phrase.
So I think agentic RL won't be solved. The bottleneck is data and environment. Yeah.
Well, I still think infrastructure is the most bothered. So even now, we are already short of the power and everything else.
Yeah, I think data and environment is the bottleneck. Unless we can turn every task we care about into an IL gem for the model to help climb on.
In my opinion, I think user simulator will be one of the bottleneck, because if you really use Cloud Code every day, you will think when we use Cloud Code, we never give an instruction and let it run all the time. We usually interactive coding with Cloud Code. So if we want to train a better coding model using agentic RL, we need to consider, do we have a real better human simulation to simulate the human developer behavior in the real world?
Yeah, I would give an answer RL infrastructure. So still infrastructure, which include the environments, the harness, the inference stack, training stack, all of these things. I think it's still not very mature. Even though we have done a lot of experiments on it, we still have a lot of things to improve. Like just said, the user simulator, which is the CPU environments infrastructure we can build to improve the end-to-end performance. So yeah, I will give answer IO infrastructure still.
Sounds like we still have like a minute or so. Maybe one more. What is, just going down the line from the right to left, what is one key takeaway you want to leave the audience with based on everything that we talked about, or some other insights that's highlighted by other panelists?
Oh, sorry.
Yeah. If you want to start.
I might need to think about maybe.
Okay.
Do you want to go first?
Yeah, so I have a question in my mind since last year. So last year as a PhD student, when I first touched Cloud Code, I think Cloud Code can replace myself in like 3 or 4 years. But this year, when I deeply use Cloud Code, I think let's consider if the Cloud Code cannot replace the human developer in the end, how should we train the Cloud Code to better collaborate with human? I think it's a good question for agentic coding. Like how can the model to better collaborate with human developer?
The takeaway I'll give is that just trust RL scaling. Scaling RL is all you need to improve your model.
So I would say in the past 2 years, we have been crazy about scaling the model size. But I think we really need to slow down a little bit because of the serving difficulty now. It's becoming, gradually unacceptable. For example, when you check your Cloud Code bill, and even there are some companies they stop infinitely give away Cloud Code usage. So yeah, we need to really start thinking about if we should, focus on the training efficiency based on the model size rather than keep scaling up. There are a lot of models. They are 3T, but the efficiency behind them are very different. Yeah.
Thank you. I'll close this shortly. So I think the best loss function is going to be customer satisfaction in terms of our training. So thank you.
Awesome. All right, time is up. Thank you for your insights, and thank you for listening.